All right, so our last section for this week is going to be 7.4. Okay, and this section and the next couple sections, we're going to focus on what's called trig identities. So just as a reminder, what an identity is. Basically, it's an equation that's always true. Okay, so no matter what you plug in, it's an equation that is always true. Okay, and of course, the values that you plug in have to be things you are allowed to plug in. Like you can't plug in something that would cause you to divide by 0 or something you're not allowed to do. Okay, but for any numbers that you are allowed to plug in, the equation is always true. Okay, here's an example of an algebraic identity. Let's say 2 times x plus 3 equals, let's do x plus x plus 1 plus 2. Okay, so if I gave that equation in Algebra 1 and asked them to solve it, okay, if you go through what properties you need here, watch what ends up happening. If you distribute on the left-hand side, what do you get? 2x plus 6. And then if you combine like terms on the right-hand side, what do you get? So you end up with 2x plus 6 equals 2x plus 6. And then you could subtract 2x from each side, and now the x's are gone. And you get 6 equals 6. Okay, well that's an identity. Okay, what that means is you can pick any value for x, positive, negative, fraction, decimal, doesn't matter, and it will always make this equation true. You can't find a number that would make this false. It's an identity. It's always true. Right? So we're going to look at things like this, except they're going to have trig in them. Okay? They're not going to be algebraic identities that are true. They're going to be trig identities that are always true. Okay, so we should already be familiar with some of the identities. Okay, as I mentioned, just to type in like secant, cosecant, and cotangent, you have to know the reciprocal identities. All right. So I think we started looking at some of these identities in chapter 6. Okay, but if you need to copy any of them again, you can. And they're all on page 403. Okay, identities usually are not something you memorize other than what we call the fundamental ones. Okay, these are the 11 basic identities that we should know. If you're wondering how many more identities are there, hundreds. Okay, there's hundreds of identities that you can have, but they're not something you usually memorize. Okay, an identity is something, if you need it, you look it up in a book. Okay. And really the goal of working with identities is they're going to give us something that looks kind of complicated, and we're going to use these formulas to simplify it. So we're going to take something that looks complex and simplify it to something that looks a lot easier to work with. As far as the application, we're not really going to get into word problems or anything like that. Okay, so all we're going to do is really the first step, which is to take an identity and use it to simplify a problem. In this class, we won't really be applying it.
Does that say 1 plus tangent x or 1 divided by tangent x?
This one is 1 plus tangent squared x on the bottom. I can make those a little bigger. Okay, I don't know if these are all in the front or back cover of your book. I know they're on page 403, but most trig books, calculus books, if you look like on the front or the back cover of this book, it has all the trig identities that I'm telling you about. Okay, this book has even more. It's got the fundamental ones, and it's got ones we're going to talk about, but we haven't gotten to yet. Okay, if you don't see them on the on the cover, at least you know they're on page 403. You can find them there. Okay, does anyone else still need to copy?
Yeah.
So calculus is where you see more of the applications of identities, okay? But again, I'm not going to get into that as much here. All right, so there's a few different tricks to simplify identities. Okay, there's really three basic tricks that we need to know. Okay, and one of the tricks is if you have a problem where there's things in it that don't have sine and cosine, we're going to change everything to sine and cosine. Every single trig function, whether it's tangent, cotangent, secant, cosecant, can all be written just using sines and cosines. Okay, you can write tangent as sine over cosine. You can write cosecant as 1 over sine. Okay, so sometimes writing things as sine and cosine, it just helps us to cancel some things out and simplify the problem. All right, so we're going to try to simplify that one. It's our first identity. It's cotangent divided by cosecant. Now, it doesn't matter what the angle is. Okay, could be 10 degrees, 15 degrees, negative 8 degrees. Okay? This is an identity. It's going to be true no matter what angle we would use it for, if we were going to apply it in a problem. All right, so let's start with the numerator. Okay, cotangent. How can I write cotangent in terms of sines and cosines? Okay, we could do 1 divided by tangent. In this case, that identity is not going to help us, but we might use that in a later problem. Yeah.
Cosine over sine.
Cosine over sine. Okay, so the top becomes cosine over sine. And what about cosecant? That's 1 over sine. Okay, and now we have two fractions with the same denominator, and we're dividing them, so the denominators cancel. Or, if you don't like to think of it that way, some people think of when you divide a fraction by a fraction, you flip the one in the bottom and multiply by the one in the top. Okay, either way you think about it, what ends up happening is the signs cancel. Okay, and once the signs cancel, what am I left with? Cosine. Okay, so basically what this is saying is if you took the cotangent of any angle and divided by the cosecant of that angle, it's really just the same as taking the cosine. Right? So why do it more complicated if you can do something simpler? Okay, and then in calculus, if we had to work with this expression, it's a lot easier because it's just a single trig function by itself rather than having two trig functions with a fraction. Okay, that's a lot simpler, and it's the same thing. That's basically what we're doing today. That's an easy one. Some of them get harder, but that's the basic idea. Okay, any questions on that one? Okay. Let's try this one. Cosecant times tangent. This is the kind of problem, again, I would change everything to sines and cosines, and hopefully when you do that, something cancels out. Jamie, if I start with cosecant, how can I write cosecant as a fraction with sines and cosines? So sine over cosine, that's going to be good, but that's for the second part. sine over cosine is tangent. Think if you were going to plug this in on your calculator, how would you type in cosecant? Yeah? 1 over sine. Okay, and now when I multiply those together, Nick, what's going to happen there?
The signs will cross out and get 1 over cosine.
Yeah, sines cross out, and I get 1 over cosine. And what's 1 over cosine? Secant. Okay, so there might be a question, well, should you just stop at 1 over cosine, or should you change it to secant? I would argue that something that has a fraction is more complicated than something that doesn't. So I would get rid of the fraction if you can, and write it as secant. That's it. So the cosecant times the tangent is the same as just taking the secant. Any question on that one? All right, so there's a couple different kinds of directions the problem can give us. They can say simplify, okay, which is like the last two. So you just take what you have and you just try to go as far as you can till you think you're done. And then there's verify. Okay, verify is a little bit nicer because when they ask you to verify, okay, they're basically giving you something to start with. They're telling you the answer. All you have to do is simplify it till you get that answer. So it's like you know where to start, you know where to stop. It's like you fill in the steps in the middle. With simplify, you don't really know where to stop. Okay, it's like, well, should I stop at 1 over cosine? Should I stop at secant? You don't know. Okay, that's why verify is a little bit nicer. Okay, so we'll try some verifies in a little bit. I want to try, I think, one more simplify, and then we'll try some of these. All right, so changing everything to sines and cosines. Okay, that's one trick. Okay, another trick, I usually try to start with the side that looks more complicated if they're asking me to verify. Okay, that's what I do. I always start with the side that's more complicated and try to simplify it, rather than take something that's simple and make it more complicated. Right, so if I was doing this problem, I would start with this side and try to simplify it. Don't start with something that's simple and try to make it look more complex. Okay? So any questions on the difference between simplify versus verify? All right, so we'll do a verify in a second. Let's try one more simplify first. Okay, so this one we don't know where to stop. We're just gonna keep going till we get an answer that looks pretty simple and we think we can't do anything else with it. Okay, so hopefully that'll be pretty clear as we go through. Right, so it says sine of theta, and then in parentheses, cotangent plus tangent. Okay, what do you think I could do first here?
Change cosine, whatever, COT and tangent.
All right, so we could change cotangent and tangent to sines and cosines. We're going to have to do that at some point. There's also something else we could do first. A property that we've used a lot. We haven't used it today, but you use it in Algebra 1 all the time.
Distribute?
Yeah, we can distribute the sign. The order you want to do it in, change to sines and cosines and then distribute, or switch that order, it doesn't matter. I'm going to distribute first. Okay, so that's going to give me sine cotangent plus sine tangent. Now I would change everything to sines and cosines. this already is a sign. The only thing I'm going to do if I'm going to change things to fractions, maybe I want to make sine a fraction just by putting it over 1. Okay, what about cotangent? Make that cosine over sine. Okay, sine, we can just leave it. And what about tangent? Sine over cosine. Okay, so now when we multiply, you can cancel things that are right next to each other, but you cannot cancel things across a plus or a minus sign. All right, so if you think, oh, there's a cosine in the top here and a cosine in the bottom, there's a plus sign. You can't cancel across a plus sign. But you can cancel across a times sign. And that's pretty much all that happens there. Right, so we end up with cosine. Denominator is just 1. Plus, what's sine times sine, you think? Yep, we get sine squared over cosine.
You don't do that.
Okay, so now changing to sines and cosines isn't going to help at this point. Okay, everything already is a sine and a cosine. We have two fractions and we want to add them together. Okay, but if you want to add fractions, what do you need to make sure you have? A common denominator. Okay, and that's our second trick, okay, which I'm going to copy and paste right into this problem. So without this trick, we would be stuck at this point. Okay, so a second trick for identities is to write with a common denominator. Okay, easiest way to find a common denominator is just take the two that you have and multiply them together. So if you had something like 3/4 plus, let's say like 7/3, okay, and you wanted to find a common denominator, I would just do 4 times 3 is 12. And that's my common denominator. All right, so just take the two that you have, multiply them together. All right, so what do you think my common denominator is going to be here? Cosine. Okay, the fraction on the right already has it. So don't change that one at all. It's fine. What about the fraction on the left? What do I have to multiply top and bottom by to give that the common denominator of cosine? Yeah. So let's go like this. So we want to have a denominator of cosine. So multiply top and bottom by cosine. Now you've got the common denominator in the bottom. What does the top become?
Cosine squared.
Cosine squared. Okay, and now if we wanted, since they have a common denominator, we really don't need to write it twice. We could just make one big fraction and put the whole thing over cosine. Okay, if you want to leave it separate, you can for now, but really, you just have one fraction. All right. So I want you to look at that top. Okay, cosine squared plus sine squared. Okay, I'm going to go back to something. Does anybody see that somewhere? That's a Pythagorean identity. It's not exactly the same. The order is switched, but you can rearrange these identities. So what is cosine squared plus sine squared? 1. So that whole numerator in that fraction we had, because of that identity, just turns into a 1. So now we get 1 over cosine. And that's secant. Yep. Okay, so that one was a little bit harder because it had a few tricks in it. Change to sines and cosines, find a common denominator, and then use a Pythagorean identity. Okay, if you don't recognize this as a Pythagorean identity, we're stuck. You're not going to be able to do anything. Okay, so it's good when you're doing these to have that, maybe have a sheet next to you with the identities, so you don't have to keep flipping. You can just look at your identities. Okay, any questions on that one? All right, let's try our first verify. Okay, so with verify, again, they're going to give you a side that looks simplified. They're going to give you a side that looks complicated. Our goal is going to be to take the complicated side, turn it into the simple side. If we can do that, we're done. Okay, so for this whole problem, just leave sine theta on the left. You're never going to do anything with it. We're just going to try to rewrite the right-hand side. Okay, any thoughts on what I should try to do to the right-hand side? Yeah, I would write everything as sines and cosines. Sometimes we don't know what's really going to happen when we do that. We're not sure where we're going. But try it and kind of see what happens as you get going. Okay, so I'm going to write secant. 1 over cosine. Tangent is sine over cosine. And cotangent is cosine over sine. Now, honestly, from the first step to the second step, I think it looks worse now. But a lot of times, as you verify an identity, sometimes it starts to look a little bit worse before things cancel out, and then it looks better. Okay. We know we're going to get a very nice answer in the end, so let's keep that in mind.
That would be good.
Can you cancel across a plus sign? No. Okay. If that was multiplication, you could cancel, but not across a plus or a minus sign. All right, so we got everything as sines and cosines. What else? What could I do now?
The cosine on top, like the bottom of it, and then the bottom of the cosine on the bottom, like from the correct to the left. You know what I mean?
Can you say that one more time?
Can you cancel the cosine on top and then the cosine on the bottom of the
Oh, no.
fraction? Has
No.
to cancel out of all of it.
Unless there was a cosine here, here, and here. Yeah. Any other thoughts what we could do? It's a trick. We did it in the last problem. We'll just try it again here and see what happens. Okay. Focus on the bottom.
Couldn't you multiply by cosine theta sine?
Okay, you want to multiply top and bottom by cosine theta sine theta? Yeah, you could, as long as you do the same thing to the top and the bottom. And by doing that, it's going to cancel out some of our fractions. Okay, it's not the way I was thinking, but we can try it. Okay, there's lots of different ways to solve identities. I was thinking common denominator here. Let me see. So if we multiply everything by, you want to multiply by cosine sine? Okay, so we're going to multiply the top by cosine sine and the bottom by cosine sine. Okay, I haven't tried it this way, so I don't know how this is going to work. What are you left with in the top if you do that?
Sine.
Just sine. Okay, the cosines cancel. Okay, and now in the bottom, you have to distribute that to both. So if I multiply cosine sine to the first fraction, what would cancel out?
Oh,
Cosine?
The cosine. because you'd have a
It'll
cosine.
be sine squared.
Yeah, you're going to get sine squared in the top. And then the cosines would cancel out because this cosine's in the bottom. Think of it like that. That cosine is in the top. Okay, if you did that to the second fraction, what would cancel here?
Sine.
Yep, sine in the bottom, sine in the top. And you're left with cosine times cosine, which is cosine squared. And now this whole thing, because of that Pythagorean identity we used last time, turns into 1. So you're left with sine divided by 1, which is just sine, which is what they wanted. Okay, so that trick worked very well. The way I was going to do it would have been to find a common denominator, and you still would have used this Pythagorean identity, but I think I like that way a little better. Okay, any question what we did there? Just
So you
multiply
multiply by,
all that to that.
I already get that, but you just have to like make it up, like you just multiply by what we have on the denominator.
My guess is that Tyler looked at his denominators and said, what could I multiply by to get rid of all these fractions? So if you multiply by, almost like you're finding a common denominator. Okay. If you multiply by your denominators, they cancel out. Okay, one thing about identities is there's many ways to solve them. Okay, some ways you could try doing this and it may turn into a 20-step problem. We did this problem in about 3, maybe 4 steps. Okay, so if you find yourself doing an identity and it's starting to turn into like this huge problem, just stop and start over and try something else. Because there's an easy, well, relatively easy way to do every problem. Okay. Yeah.
Why wasn't it 1 over sine multiplied like that? And then you have to multiply by the like whole fraction.
You mean in the bottom?
Yeah, when you multiply by cosine.
So the first fraction is sine over cosine. And then we're multiplying by a cosine sine. Both in the top.
Oh, they're full.
Yep. The cosine and the sine are both in the top. So that gives you sine times sine. And then it's similar in the second one. Okay. Big thing, make sure you remember is that you distribute it to both. Great. All right, so our third and last trick for identities, okay, if changing to sines and cosine doesn't help us, finding a common denominator doesn't, we could also use a conjugate. Okay, we used conjugates before when we had problems like this. And I said to divide these complex numbers. Okay, the way we would do this, if I asked you to divide complex numbers, we didn't divide. We multiplied by the conjugate. And then we FOILed everything out. All right, so 3 minus 4i, 3 plus 4i, those are conjugates. Okay, so to find a conjugate, all you do is change the sign. Right? If you had 8 plus I, the conjugate is 8 minus I. If you had tangent x, let's make up something simple, tangent x minus 2, the conjugate is tangent x plus 2. Okay, just change the sign, and that's the conjugate. And it doesn't say the conjugate has to be in the bottom. When we did complex numbers, that's where it usually was. But maybe our conjugate will be in the top, maybe it'll be in the bottom. Okay, when you see the problem, I think you'll be able to figure it out. Okay, any question on what a conjugate is? All right. Okay, so this one is another verify. And my suggestion is to always start with the side that looks more complex. In this case, I would say both sides look about the same. Okay, they both have fractions. One of them is just a single trig function. The other one has 1 plus or minus something. Okay, so they're pretty much the same. So we can start with either side. Okay, you guys want to start with what's on the left or what's on the right? Left? Okay. So what we're going to do is take what's on the left and somehow turn it into what's on the right. Okay, so forget about the right-hand side. Okay, we'll look back at it when we're all done. Okay, how come changing to sines and cosines wouldn't help me at this step? It already is. Okay, common denominator is not going to help me either. I don't have two separate fractions. I have one big fraction already. So I can't do a common denominator. So the only trick I have left is multiply by the conjugate. Do you think the top or the bottom here has a conjugate? Bottom. You don't have a conjugate really that would be helpful for just a single term. Okay, so what's the conjugate of 1 minus sine?
1 plus sine.
1 plus sine. And it's by introducing the conjugate, look what's in the final answer. 1 plus sine. Okay, so we just introduced something that should be in the final answer. It's got to be a good thing. All right. Now we have to distribute things out. Okay. I'm not going to distribute what's in the top. Okay, the reason? I'm looking at my final answer. My final answer is supposed to have a 1 plus sine in the top. Right now, I have a 1 plus sine, but I also have a cosine. So I'm hoping that that cosine just disappears somehow. If it does, then I'll be left with what I want in the top. Okay? So don't distribute this out, because we're going to hope cosine just goes away somehow. We'll go through the problem and see what happens. Okay, so I'm just going to leave it as cosine 1 plus sine. And now the bottom, we want to do that out. Okay, so we just FOIL it. What's 1 times 1?
1.
You get 1. What's 1 times sine?
Sine.
And what's 1 times negative sine? So what happens with positive sine and negative sine? They cancel. 1 times sine, 1 times negative sine. Those are gone. I have a negative times a positive. That's a negative. What's sine times sine?
Sine squared.
Sine squared. Okay, now, again, I want you to look carefully at this bottom. 1 minus sine squared. Okay. Let's go back and look at our list. Okay, it's almost this identity. Okay, the only thing they've done is this. They've taken this identity and just moved something to the other side. So cosine squared equals 1 minus sine squared. Okay, you can do that with the identity. You can take and put something on the other side by subtracting it. So 1 minus sine squared is cosine squared. Any question on that? Just subtract sine squared to the other side. Okay, now let's go back and look at our problem. We had a 1 minus sine squared. Okay, what did we just figure out 1 minus sine squared turns into? Cosine squared. So in the bottom I get cosine squared. In the top I have a cosine. What do the top and the bottom both have in common? Cosine. How many in the bottom? 2. How about in the top? 1. So you can cancel 1 from everywhere. 1 from here. And look at what just happened. What I was hoping canceled out did. Now, if you had distributed it, because sometimes you're starting out, you're not sure to not distribute something, that's okay. It's still going to cancel out. It's just you're going to distribute something, and then you're just going to cancel it in the next step. Since I knew that, that's why I didn't distribute it. And now I'm left with 1 plus sine over cosine. 1 plus sine over cosine. Okay, any questions on that one? Okay, as I'm going through them, I'm probably making them look very easy. because I've done thousands of them. As you're going through them, don't get discouraged if you get stuck. You will get stuck, okay? This is one that I'm going to let you guys just kind of play with on your own a little bit, see if you can figure it out. There's several ways to do it. Okay, one way is very easy. One way, it's a trick we learned today, but if you do it in this problem, it actually makes it very hard. Okay, it turns it into a very long problem. Okay, so play with it a little bit. You'll probably get stuck. That's okay, but then we'll go through it together and see what happens. Okay, so just to kind of recap, if you try changing to sines and cosines, it will work, but it turns out to be pretty long. Okay, Upi's suggestion was change everything here to tangent. Okay, so leave tangent x the same. Right, cotangent, how did you do that, Upi? 1 over tangent. And then in the bottom, do the same thing.
Is this the right way to do it?
Yep. Plus 1 over tangent. Now, here you can use a trick that Tyler gave us earlier. Okay, it was kind of like this problem. We had these fractions and we multiplied by something to get rid of all of them. Okay, what could you multiply the top and the bottom by to get rid of all my fractions? I want to cancel out my denominators. Let's multiply by tangent. But if you do it in the top, you have to do it in the bottom. Okay, let's see. What's that first term going to be when I do tangent times tangent?
Tan squared.
Tan squared. Okay. What's going to happen when I multiply it to the second term?
-1.
Yep. -1. Okay, those are going to cancel out. And now look, the top is already exactly what we want. Tangent squared minus 1. And now the bottom, it's the same thing except it's a plus. Okay, so we've got the top the way we want it. The only thing we don't have is the bottom. Okay, but look carefully at that. Tangent squared plus 1. Yeah, that's an identity. Tangent squared plus 1 is secant squared. So that entire bottom turns into secant squared, and you're done. Did anybody, whoops, I went too far down. Did anybody get that one? That first step? Okay, any questions on how we did it now that I showed you? Okay, so sometimes it's that first step that's really important. If that step goes wrong, it kind of sets up the rest of the problem to be difficult. Okay? But, bless you. I wouldn't expect most people to get this one right out of the bat. I would expect you to change to sines and cosines, because that's what we've tried. And I'd say 90% of the time, that's what you want to do. This problem's a little different. Okay, any questions on that?
Wait, so is that the answer?
Yeah, we wanted to get tangent squared minus 1 over secant squared. Tangent squared minus 1 over secant squared. So we turn the right-hand side into the left. Okay, this one, I'm not going to go through it. I'm just going to kind of explain what you do. Okay, this is one that's not a proof. It's something you would do before you start doing the proofs we've been doing. Okay, let's say I said to you, I want you to prove if what's on the left and what's on the right are equal. Okay, if you can. Right? Now that's tricky because I'm saying, well, maybe these are equal, maybe they're not. if you want to test and see, should I even try to prove this, or are they not even the same thing? You can graph this in y1. You can graph that in y2. And if the graphs look the same, then chances are this is something you can prove. If the graphs look totally different, then this is not something you could prove. Okay, so using your graphing calculator would be a good step if they give you a problem and say, prove if possible. Okay, a graph itself is not a proof. Okay, just because two graphs trace over each other in the same color, that doesn't prove anything. This is a proof. Okay, you got to go show the algebra. Okay, so any questions on that idea? Trying to determine if something is something you should prove?
So if it's on the calculator and doesn't line up, we just write no solution?
Yeah, if y1 and y2 look totally different, I would say the graphs are completely different. There's no way that these two things are equal and they couldn't be proven to be equal. Yeah. Okay, so that's how you could use a graphing calculator to help you on a problem that says prove if possible. You don't want to waste your time trying to prove something you can't prove. Okay, so you can use your calculator to help you. We'll skip that one. Okay, these are just more practice. There's nothing new in these problems we haven't done today. All right. So our homework tonight will be on 407. Okay, it's 4 through 8, 11, 12, 21, 22, and 25 to 27. Okay, not a lot of problems, but they're identities. So you might get stuck on them, but just do the best you can. Okay, and then tomorrow I've got a worksheet that will help us review for the test.